Hello, good morning.
Morning, sir.
Okay, so okay, good morning, all of you, and we all most finished the syllabus. The last point is the routing protocol concept and interior and exterior routing protocol. In the last class, we already gone through this interior and exterior routing protocol through the web information, not through this PowerPoint slide. I already update those PowerPoint only in this interior routing protocol. I'm not added up this exterior. We'll do it in the in the next class. And after completing this one, we're going to review the revise or review the syllabus. Also, we're trying to do the assignment also. I'll give you the assignment for each and every in each and every unit. So let's go on through this interior and exterior routing protocol. And also I already uploaded in the Moodle also this slide, unit 4. Interior gateway are gateway that's belong to the same autonomous system. I already explained that autonomous system. This is the internal routings of the organization, a company, or any enterprise. They have their own routing rules and routing system. This is called autonomous system. They communicate with each other using these routing protocols. Number one is the routing information protocol, RIP. This is version 1, and also we can have a version 2 also. And routing information protocol next generation also there. Apart from this, a version 1 and a version 2. And the third point is ISIS, intermediate system to intermediate system protocol. And the last point in this interior gateway protocol is the open shortest path first, OSPF protocol. Let's see the first point, RIP. RIP is the routing information protocol. It is an intra-domain, means intra-area. In the internet also we can say that two types of communications in this interconnections. If we say intranet, okay. If we say intranet, this is in a local area network, okay. Intranet or internet. This is local area network communications within the LAN. Okay, communications within the LAN is called the intranet. Not going outside to the network. In our IP address system, addressing system, especially in the IPv4, we have two type of addressing. First is the private address and the second one is the public IP. If it is the private IP, this is the local IP, is non-routable IP. We have to use only in the local area network. But if it is public IP, then this is the routables, then it can goes out to the networks, it can route by the routers. So intranet and internet are there. RIP is an intra-domains, means internally, okay, internally domain routing protocol used within the autonomous system. So it's very clear that RIP is the intra-domains, interior, okay, intra-domains protocols used within the autonomous system. Here intranet means routing the packet in a defined domain. There are some specific domains in the intranet, intra-domain. Intranet also we have a specific network area, whether a LAN or a MAN. So all these are networked together by using a defined area in the intranet. Okay. Here in the intra-domain routing, the packet is defined in a specific area, specific domain. Let's say web browser within the institutional area. Okay, these are the examples. Some intra-domains having the browsing facilities and all these things within the campus area only, that cannot go out to the external network. So to understand the RIP protocol, our main focus is to know the structure of the packets. So we have to understand how the packet travel across the routers in the interior routing protocol in autonomous system. How many fields it contains and how these fields determine the routing tables. So how the routing tables forward the packets and all these things, we have to know the fields. Okay. RIP message formats are there in this table. Also we have format. The structure of RIP message format. The message format is used to share information among different routers. The RIP contains the following fields in a message. So these structures, RIP structures, forwarded back and forth within the intra-domains, within the intra-domain networks. So here we have different types of content in the fields. Okay, RIP message field. Let's see in detail of this. RIP field content. command, version, reserved, and network, and distance. These three are the content of the routing, routing information protocol. Number one, command. Command is an 8-bit field. So this is the 8-bit. This is the 8-bit field of RIP packet that is used for request or reply. The value of the request is 1 and the value of the reply is 2. So you have to remember in the RIP protocol, in the command, this is 8-bit field, 8-bit data field. If the value of the request is 1, the value of the request is 1 in the command field and the value of the reply is 2. Okay, request 1, reply 2. So in the command we have two types of value, 1 and 2, request and the reply. And version, here version means that which version of protocol we are using. Suppose we are using the protocol of version 1, then we put 1 in this field. So under this RIP we have different types of versioning: version 1, version 2, and RIP next generations also there. So this version field contain these 3 different types of routing information protocols. Point number 3, reserved. Reserved fields is a field with zeros. So all zeros are there. This is a reserved field. So for communicating the 2 devices of the routers using 3 types of routing information protocol, we have to convey some informations. So we need to have a reserved field to edit some information. So it is initially filled with zeros, all zeros. Then family, it is 16-bit field. As we are using the TCP families, so we bit 2 value in this field. So family is a 16-bit field. It contains a 16-bit. This will classify the protocol used in the communications, maybe UDP or SMTP or ICMP or any other things. So if it is the TCP family, then it's contained 2 in this field. So it's clear here what is a version, what is reserve, and what is family. And let's go to the next point, network. It is defined as 14 bytes fields. It was use the IP version 4. So if we use the IP version 4, then we use 4 bytes, and the other 8 bytes are all 0. So network address is defined as a 16 byte field. So it can contain 16 byte field, but if we use this IP version 4 for communication, for addressing the device, then here it's use 4 bytes and the others 10 bytes are all zeros. So the size of this network address is 14-bit. If it is used 4 bytes for the addressing system, what is 4 bytes? 4 bytes IP version 4 is the 32-bit addressing system, so we need the 4 bytes, and the other 10 bytes are all zeros. Okay, it's contain all zeros. Last point, distance. The distance field contains specifies the hop count. Okay, it's this field contain the number of hop count, that is the number of hops used to reach the destinations. I hope that you already clear about the hop count. Let me explain a little bit about this hop count. How we are going to count the hop. The router itself check the hop count, or we can say that number of routers passes to the network to reach the destinations, as we see here. So if the packet starting from the first router, the intermediate router, then it forwarded to the neighboring routers and so on. So it's passed through 5 routers and it reached the destination. Then the number of hop count is 5. So this is the example of the hop count. And apart from this hop count, you can have the time to live also. Time to live also based on the number of hop count, how many routers passed through the network to reach the destination. Here in this TTL, time to live, in this time to live, we have a starting value, the standard starting value. If the TTL is 112, let's say, then we send out the packet from the first router to the second router, neighboring routers. So neighboring router accept this information packet and forward it to the next routers. Then it's decremented by 1 of the TTL, time to live. Then each and every hop count in the network, in the routing network, is decremented this TTL value until and unless it's reached to 0. Okay, equal to 0. So if it is equal to 0, then it's removed If it's reach 0, then it's remove the packet from the network. It's remove the informations, okay, packet informations in the network. So here hop count and TTL, time to lifts, are interrelated in this the interior or the exterior routing protocol. Okay. Interior routing protocol, RIP, of interior routing protocol, sorry, of routing information protocols, advantages and disadvantages. Let's see here. The followings are the disadvantages of the RIP. In RIP, the router is chosen based on the hop count matrix. It's calculate the number of hop count matrix. How many hop count to reach the destination? So sometimes the to reach this router 3, from router 1 to the router 3, maybe 1, 2, 3 via router 4, 1, 2, 3, 4 to reach this router 3. In between this we have 2 routers, okay. And here from this to reach this one, here we have 1, 2, 3, 4, and the fifth positions it reaches the routers. So based on this number of hop count, then it can decide that the shortest route, okay, the shortest route. If another routers of better bandwidth is available, then that routes would not be chosen. Let's under this understand this scenario through this example in this graphic. And the advantages is it is easy to configure the routers, okay. It is easy to configure this RIP. It has less complexity, so RIP does not have the routing complexities than the checking those routing tables and all, and it's having less CPU utilization, okay. So these are the advantages and the disadvantages of the interior routing protocol. How is update the routing tables in this RIP? It's having this 3 types of timer settings, okay, 3 types of the timer settings. Number 1 is RIP update timer. This is 30 seconds. The router configured the routers configured with RIP sends the update to all the neighbor routers every 30 seconds. So it's update all this information, routing informations, to the neighboring router, adjacent routers. Okay, it's update those informations. RIP invalid timers 180 seconds. The RIP valid timer, yes, in invalid timer is 180 seconds, which means that if the router is disconnected from the network or some link goes down, then the neighbor routers will wait for 180 seconds to take the update. If it does not receive the update within 180 seconds, then it will mark the particular router as a not reachable. So the RIP send their updates to all the neighbor routers every 30 seconds. That's very clear. It sends each and every router sends back and forth its routing tables. It's okay. But if there are some link or the router is down or unplug or plug out all the network cables, then this create problems in the updations of the 30 seconds. If the router is down, then it cannot receive, it cannot reply, it cannot send out signals. So RIP valid, so invalid timer is 180 seconds. Once the router arrived, that's a packet arrived to the routers, then we are having this features. Okay, if this goes down, okay, then the neighboring routers waiting the packets is working the packet, then within this 180 seconds it does not receive this updates from the neighboring routers, then the routers detect that the routers is non-reachable. Okay, non-reachables. So disconnect from the network or some link goes down, then the neighbor routers will wait for 180 seconds to take the update. So these are the timer, RIP invalid timers. Okay, how it worked. The third point is RIP flash timer. RIP flash timer is 240 seconds, which is almost equal to 5 minutes. Means that if the router does not receive the update within 20 seconds, receive the update within not 20 seconds, 240 seconds, then the neighbor routers will remove the particular routes from the routing tables, which is a very slow process, of 4 minutes in a long time to wait. So these are the processes in this routers, how it's update the information using this RIP protocol. Number one is the 30 seconds routing table update. Number two is the 80 seconds invalid timer. 180 seconds means within a given period, if it does not reply, it did not receive the reply or the request. And the last timer is the flash timers. It's needed to flash some information inside the routing timers. So it indicates such type of okay. These are the timer maintains in this routing information protocol. Okay, let's move on to the RIP next generations. Okay, RIPNG next generations is the protocol version 6 available. Next level protocol of the RIP version 2. Version 2 does not have this compatibility of this IP version 6. Okay, so in this next generations is compatible with this IP version 6. In modern large networks, generally RIP is not used and also RIPNG, but as a basic protocols, it is still used in many small networks. Basically, the characteristics of those version of two versions is same as we discussed before in the RIP articles. RIP-NG have the below similar characteristics of the characteristics as RIP version 2. Number one is distance vector protocol. It's use distance vector protocol to check to identify, you can say, to identify the shortest path. Okay, to identify the routes of the packets within the routing network. And number two is it's use the hop count matrix for distance vector protocol. The default administrative distance is the 120, the hop count, the number of hop count. Okay, up to 120 distance. Beyond this is cannot estimate the distance vector. Uses split horizontal Poisson reserve reverse. Okay, horizontal control and Poisson reserve, and uses periodic and triggered updates, 30 seconds periodic and triggers updates. Okay, these are the points in this RIP next generations. As you can see above, RIP-NG next generation is almost same as RIP version 2, but there are some additional differences because of the IP version. Okay, IP version 4 RIP version 1 and 2 supports only this IP version 4, but next generations RIP support the 16-bit IP version 6. Okay, okay, in this interior routing protocols, the next point is the ISIS, intermediate system to the intermediate system. This ISIS protocol is one of a family of IP routing protocol. And it is interior gateway protocol in the for the internet, used to distribute IP routing information through a single autonomous system AS in an IP network. So this ISIS is the protocol in this IP routing protocols. Okay, it's a protocols in the IP routing, and this is the interior gateway protocol for the internet, used to distribute IP routing information through a single autonomous system. Okay, ISIS is the link state routing protocol, which means that the routers exchange topology network topology, how is connected the neighbor network. Exchange topology informations within their neighbors. The topology informed is plotted throughout the autonomous system so that every router within the autonomous system has a complete picture of the topology of the autonomous systems. This picture is in the last pictures we already explained that these things calculate the end-to-end path through autonomous system normally use a variant of Dijkstra algorithm. Dijkstra algorithm is the search technique in the binary tree system. Okay. Therefore, in a linked state routing, what is the use of this Dijkstra? Dijkstra, based on this Dijkstra algorithm that other also we already learned in this let's say in the data structure also. This Dijkstra is the data structure type in the binary tree. Okay, in the binary tree. So this tree is almost same with this network management. So it's implemented in the network, this Dijkstra algorithm. Originally, this is the tree algorithm, binary tree or any other tree algorithm. Okay, we can learn it. If you want to go in deep, then you can learn this Dijkstra algorithm. Therefore, in a linked state routing protocol, the next hop address to which data is forwarded is determined by choosing the best end-to-end path to the eventual destination. So it's calculate the best path, the best routing path by using this Dijkstra algorithm. Okay. The main advantages of linked state routing protocol is that complete knowledge of the topology allows router to calculate router that satisfy particular criteria. This can be useful for traffic engineering purpose, where routes can be constrained to meet particular quality of the service requirements. The main advantages of a linked state routing protocol is that it does not scale well as more routes are added to the routing domain. Increasing the number of routers, increasing the size and frequency of the topology update, and also the length of the time it takes to calculate end-to-end routes. This lack of scalability means that a linked state routing protocol is unsuitable for routing across the internet at large, which is the reason why IGP only routes traffic within a single AS. So this intermediate ISIS is only compatible within the small scale networking environments. If we target the large scale or the intranets, then this is not feasible. Okay, ISI is not compatible in the large network. And what is the advantages of this? That it's very easy to implement also. Each ISIS router distribute information about its local state, enable interface and reachable neighbors, and the cost of using its interface. So I'm using every router is having this different type of interface that we can say the logical or the physical backup. Okay, so let's see here. This ISIS distribute information about its local state to other router using the link state video message. Each router use the received message to build up an identical database that describe the topology of the autonomous system. So this ISIS is a simple one in the interior gateway protocol. Let's see some point here. Intermediate system. From this database, each router calculates its own routing table using the shortest path or Dijkstra algorithm. So it's sorted out, it's calculate the shortest path using this algorithm, and also it's implemented this OSPF, open shortest path first, about associated with the next hop IP address and outgoing interface. The protocol recalculates routes when network topology changes using the Dijkstra algorithms and minimize the routing protocol traffic that is generated. It provides support for multiple parts or equal cost. If provides a multiple level it is provides support for multiple parts of equal cost. It's provide the multiple level hierarchy called area routing, so that information about the topology within the defined area of autonomous system is heading from the routers outside their network. This enhance an additional level of routing protections and reductions in routing protocol traffic. All protocol exchange can be authenticated so that only trust router can join in the routing exchange of the autonomous system. So this authentication is very important. In this, some people can hack the routers. Okay, can hack the routers if it's not properly secure. So for getting through this, we need some authentications. Okay. Okay, these are the important interior routing protocol. Let's go to the last point, OSPF protocol. OSPF, also link state routing protocol, that is used to find the best path between the router and destinations router using its own shortest path. OSPF developed by the IETF. As on the Interior Gateway Protocol, IGP, the protocols which aims at moving the packet within the large autonomous system or routing domain. It is a network layer protocol which works on the protocol number 89 and uses the value of 110. OSPF uses multicast address, so the difference is that as compared with the previous interior routing protocol, that OSPF uses this multicast. It doesn't broadcast anything. RIP broadcasts and ISIS also broadcasts. So OSPF is not a broadcast. This uses the multicast address. For normal communications, it uses this multicast address of 224.0.0.6, 224.0.0.5 for normal communications, and for 6 for update and designated routers. Okay, designated routers, and also backup designated routers, BDR and DR. Some of the important terms of the OSPF protocols are routing ID. It is the highest active IP address present on the routers. First, highest loopback address. It considered if no loopback is configured, then the highest active IP address of the interface of the router is considered. So there is no loopback, then it considered the highest active IP address, okay, of the interface of the routers is considered. And next point, number 1 is the router ID, then number 2 is the router priority, how to give the priority. It is an 8-bit value assigned to the router operating system, router operating OSPF, used to elect DR, designated routers, and BDR in a broadcast network. Okay, BDR is the backup designated routers, and DR is designated routers. Okay, these are the two important point. These are the important point in this point or terms in this open source part. First, let's see here what is the DR, designated routers. It is an elected to minimize the number of adjacent forms. Designated routers distribute the LSA to all other routers. DR is elected in a broadcast network to which all the other routers says their DBD. This is the database. This in a broadcast network, routers request for an update of the DR, and DR will respond to that request within an update. So what is the backup designated routers? BDR is a backup to DR in a broadcast network. Then DR goes down, then BDR becomes DR and performs its function. So these are the things for updating this routing information and routing tables, and also how to back up those things. So let's move on to this one, DR and BDR elections. So how we is elect all those things, selections also. DR and BR elections takes place in a broadcast network, or multi-access network. Here are the criteria of the elections, how it's elect this designated routers and backup designated routers. Router having a highest router priority will be declared as designated routers. High router priority is having this high router priority, then it's elected as a designated routers. If there is a tie in a router priority, so if there are some specific same value in the routers, then higher routers ID will be considered. Okay, router ID, higher router ID. Then in the router ID we have numerical values. Then based on these numerical values, if it is tie in this priority levels, then it's check it out in this router ID. then is considered. First, the router loop's address is considered. If no loopback is configured, then the highest active IP address on the interface of the router is considered. So these are the designated routers and backup designated routers elections. How we are going to select. Okay. OSPF states. The device operating this OSPF goes through criteria states. These states are: the initial state is down. There is nothing in the routers. In this stage, if this is idle or anything, then in this stage, no hello packets have been received on the interface. Note that the down state does not mean that the interface is physically down. Here it means that OSPF adjacency process has not started yet. Okay. After this is needed to activate the routers. So it's initiate init step. In this state, hello packet have been received from the other routers. Okay. Hello is the communications, the initiative, the initial communication packet. Okay. Before the actual communications. So in this state, hello packet have been received from other routers. Or router can also send out the packet. Okay. In the init. Next point, two-way. In the two-way state, both the routers have received the hello packet from routers from other router. Bidirectionally connectivity has been established. Note that in between the two-way state and extract state, the DR and BDR elections take place. So we have to note it down that if both in between this two-way state, in between this two-way state, the extract state, the designated routers and backup designated routers take place. And let's move on to the last slide of this interior routing protocols of the OSPF initializing of the routers. Extract. In this state, null DVD are exchanged. In this stage, master and slave elections take place. What will be the masters? Routers. What will be the slave routers? So master and slave elections take place. The routers having the neighbor routers ID become the masters, while other becomes the slave. These elections decides which over will send it. DB, this database first. Routers who have formed neighbor set will take part in the election. Exchange. In this stage, the actual database are exchanged. So loading in this state. LRS and LSU and LSA, this is link state acknowledgements, are exchanged in this loading. And important step: when a router receives this database from other routers, it compare its own database with the other routers database. If the received database is more updated than its own database, then the router will send LSA to the other routers stating that links are needed. The other router replies with the LSU contain the update that are needed. In return to this, the router replies with the link state acknowledgement. Okay, these are the steps done in this important. And the last step, full. In this stage, synchronizations of all the information take place. It synchronize the informations. Synchronize all the information take place. OSPF routings can begin only after the full stage. Then if this full stage, then the initializations, everything is completed, then it's ready to use the routers. So these are the things we have to learn under this interior routing protocol. Okay, now we finish this IGRP, interior gateway routing protocol. Next class we are going to learn about this exterior routing protocol.